Today we talk about prime numbers and composite numbers, and what makes a prime number. I will also talk about determining whether or not a number is prime, and also how to find all of the primes within a range of numbers. Let's start with a number like 12, because there's a lot of examples of divisibility. We know that 12 is a product of 1 in itself, but 12 can be divided into 2 groups of 6. Or similarly, 6 groups of 2.
Commutative law.
It can also be divided into 3 groups of 4. Or similarly, 4 groups of 3.
Commutative law.
12 can be divided into groups of 1, 2, 3, 4, 6, and 12. And by the way, these are referred to as factors of 12. Because 12 can be divided into groups other than 1 and itself, we would call this a composite number. Composite numbers are integers, or whole numbers, that can be divided by numbers other than 1 and itself. Let's look at 7. Like 12, we know that 7 is a product of 1 in itself. Can we divide it into other equal groups? Let's try 2's. Nope, that doesn't work, because we have the odd one out. Let's try 3's. That won't work either. Groups of 4's are too large because we don't have enough for 2 groups of 4, obviously because 2 groups of 4 is 8. Now you might say, wait, can we cut 7 in half? Well, if we do, we will have 2 groups of 3.5, and that won't work because 3.5 is not a whole number. 7 has only 2 factors, 1 and itself. Because it only has 2 factors, 1 and itself, we call this a prime number.
I am Optimus Prime.
There are probably 2 questions that could be asked at this point. Question number 1. Are all odd numbers prime numbers? No, they are not. Consider a number like 15. 15 is an odd number, but it can be divided into groups of 3 and 5's. So in this case, it wouldn't be considered a prime. Question number 2, is 1 a prime number? This is a tough question. For hundreds of years, the almighty mathematicians,
Gods among mere mortals,
thought that 1 was a prime number. Right now, 1 is no longer considered a prime number for 2 reasons. Number 1, it complicates the fundamental theorem of arithmetic.
Nerd alert!
Number 2, the number 1 does not have 2 factors, it only has 1 factor, 1 and itself, which is 1, so it only has 1 factor. 1 is neither prime nor composite. It's a lonely number.
1 is the loneliest number.
The sieve of Eratosthenes, 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 Eratosthenes can be used to find the number of prime numbers within a range of numbers. So for instance, how many prime numbers are there between 10 and 30? Start by setting up a 10 by 3 grid. Then put numbers 1 to 30 in that grid. Start with 1, which is not a prime number, and cross it out. Now, go to 2. 2 is a prime number. Circle it. Now think from here. Every second number is going to be a multiple of 2. 4 is a multiple of 2, so that cannot be a prime number. Then we go to 6. 6 is a multiple of 2. It can also not be a prime number. So no further multiples of 2 can be considered a prime number because they can always be divided into 2 groups. So let's get rid of all of those. And then we go to 3. Circle that number. Every single number from here on, 6, 9, 12, all of those are multiples of 3's. Alright, so we just keep going through this process until we have nothing but primes left. And in the answer to our question, there are 6 primes in between 10 and 30. Try and answer these questions. First, 8 can be divided by 2 and 4, so this is a composite number, it's not prime. 9 can also be divided into 3's, so this too is a composite number and not a prime number. 11 can only be divided by 1 and itself, so this is a prime number. 1 is neither prime nor composite, and the prime numbers between 40 and 60 are 41, 43, 47, 53, and 59. I leave you with the original questions we started with. As always, thanks for watching, and I hope this was helpful.